Falling in love is a complex, mysterious process, part chemistry, part psychology, part biology. For women, this journey is often deeply emotional, instinctive, and shaped by both evolutionary wiring and personal experience. But what exactly happens in a woman's brain when she begins to fall in love? Science offers compelling insights into how hormones, neural pathways, and psychological triggers all come together to create the emotional bond we call love. The role of brain chemistry at the heart of falling in love is a cocktail of neurochemicals that orchestrate attraction, attachment, and emotional bonding. When a woman feels drawn to someone, her brain releases a surge of dopamine, the feel-good neurotransmitter associated with pleasure and reward. This is the same chemical involved in addiction, which is why early stages of love can feel all-consuming, almost obsessive. Simultaneously, norepinephrine is released, heightening attention, focus, and memory. This explains why women in love often find themselves thinking constantly about their partner, remembering small details about them, and feeling energized in their presence. Serotonin, which usually keeps mood stable, drops during early romantic love. This dip can lead to anxious or obsessive thoughts, often interpreted as longing. In women, this neurochemical pattern mirrors that of someone with obsessive-compulsive tendencies, reinforcing the idea that love is an altered mental state, not just a feeling. Oxytocin. The bonding hormone. While dopamine fuels the initial excitement, oxytocin, sometimes called the love hormone, plays a pivotal role in bonding. It is released in large quantities during physical touch, especially during sex, cuddling, or even prolonged eye contact. For women, oxytocin can create a deep sense of trust, comfort, and connection. Oxytocin doesn't just make women feel close to their partner, it literally changes how the brain perceives that person. Studies show that once oxytocin is released, women are more likely to overlook flaws, feel greater empathy, and form a long-term emotional attachment. This is nature's way of encouraging pair bonding, especially in the context of raising children. Emotional and social brain networks. Falling in love activates regions in the female brain that are associated with empathy, social cognition, and emotional regulation. The anterior cingulate cortex, responsible for decision-making and emotional evaluation, becomes more active. This suggests that women may subconsciously assess a partner's suitability not just for romance, but for long-term partnership. The amygdala, the brain's fear and threat detector, is often less active during the height of romantic attachment. This neural suppression may explain why love can make women feel safe, trusting, and even overly optimistic about a relationship, sometimes ignoring red flags in the process. Additionally, mirror neurons, which allow people to feel the emotions of others, are highly active in women in love. These neurons promote empathy and emotional attunement, helping women bond and align emotionally with their partner. Evolutionary influences. Evolution has hardwired women to seek partners who offer security, emotional availability, and the potential for long-term commitment. These preferences stem from the biological role women have historically played in childbearing and nurturing. As such, the female brain is particularly attuned to cues of reliability, empathy, and strength in a partner. When a woman falls in love, her brain subconsciously evaluates a range of factors. Does he show signs of protectiveness? Is he emotionally supportive? Will he be a good provider or co-parent? These assessments often occur without conscious awareness but are deeply rooted in neural and hormonal responses. The power of psychological triggers beyond biology, personal history, and emotional conditioning play significant roles in how women fall in love. Attachment styles, formed during childhood, can influence how safe or anxious a woman feels in romantic relationships. For example, a securely attached woman is more likely to fall in love in a healthy, stable way, whereas someone with an anxious attachment might experience more intense highs and lows. Narratives also matter. Women are often socialized to associate love with romance, connection, and emotional depth. When reality aligns with these expectations, such as meaningful conversations, acts of kindness, or feeling seen, the brain rewards those moments with positive reinforcement, deepening affection and emotional commitment. The transition to lasting love. Initial attraction is just the beginning. As a relationship progresses, the brain shifts focus from the thrill of the chase to the stability of companionship. Dopamine levels stabilize, and oxytocin takes over, promoting long-term bonding. For women, emotional intimacy becomes increasingly important. Trust, shared values, and emotional availability act as neural glue, sustaining love through the highs and lows of life. Interestingly, couples who maintain strong emotional connections show similar brain activity to those newly in love, even after decades together. This suggests that with effort, the brain can be trained to remain in love by reinforcing the positive neural pathways formed at the start. Conclusion: falling in love, for women, is far more than just butterflies and romance. It is a deeply biological and psychological process shaped by evolution, brain chemistry, and emotional history. The female brain, powered by dopamine, oxytocin, and social intuition, carefully navigates the journey from attraction to attachment. Understanding this process not only demystifies love but also highlights the remarkable ways our brains help us connect, trust, and bond with others. And while love may begin in the brain, it is ultimately sustained by the choices and connections made by the heart.